which one you prefer. So let's get started with We Earth.
Hi, everybody. I'm going to talk to you about my little We Earth VR project that I created. Basically, it's an application that allows you to use Virtual Earth 3D using your own body and a set of 3D glasses. So Virtual Earth 3D can actually be hosted in a WinForms application. It's not a publicly documented API at the moment, but Reflector is your friend, as is that blog that I've got linked up there on the slide. So it's a little reverse engineering. You can figure out what needs to be done. So to connect up the Wiimote to the PC, I'm using my Wiimote library that I wrote about a year or so ago, which is up on Codeplex right now if you need to use Wiimotes in your life. That will connect up a Wiimote and a nunchuck and a balance board, which I'm currently standing on. Just trust me, it's down there. And these are Vuzix VR 920 glasses. These have twin 640 by 480 LCD screens. There's two accelerometers to determine pitch and roll, and a compass sensor to determine yaw. So we can actually do full 3 degrees of freedom head tracking. And it also has an API which allows you to do stereoscopic images, so you can actually render separate frames to the left and right eye. And you can pretty much take a camera that would be heading straight down the center of this room, render it a couple of units to the left, put that in the left eye, render it a couple of units to the right, put it in the right eye, and your brain will combine the 2 images together to create a 3D effect like those magic eye puzzles. You know, it's a sailboat. Somebody get the reference, please. So go to the next slide, please, Dan. So putting all this together, we've got the globe control on a WinForm. We're going to use the person's center of gravity on this balance board that I'm standing on, which kind of turns you into a human 2D joystick to get X and Y position. We're going to use the nunchuck here to move you forward and back through the environment, and the C and Z buttons to change your altitude. The camera itself in Virtual Earth is going to be controlled by the roll, pitch, and yaw sensors of these glasses. And as I said, every other frame, we're going to render the left and right eye separately to create that 3D effect. Unfortunately, no one in the audience will be able to see the 3D effect, but we have this down in our Coding4Fun area down in the big room. So if you want to come check it out, head down and we can throw the glasses on you. So the final experience here is like a fully immersive 3D ride through Virtual Earth. So why don't you switch over to the demo machine here. I think that's H. So there we go. This is Virtual Earth 3D. We've probably all seen this a million times. It's looking north on the Las Vegas Strip, which I'm going on vacation after this because I like it there. So if you were actually to look through the glasses right now, you would see a flat 2-dimensional thing just like you see on the screen here. So if I turn on the glasses right now, we can actually, if you imagine my head in here, if you move around, you can actually see the camera change positions as though you were in Las Vegas at the moment. So now I'm standing on the balance board, as I said. So if I turn on the balance board and I lean left or right, you'll see that the camera will twist with me. Ooh. And then the third piece is the nunchuck. So as we move forward, you can kind of twist and lean around and change your altitude and fly through Las Vegas and smash into the Venetian. I think that's the Paris, actually. So that's the 2D version. I'm going to show you the 3D version of what it would look like if you're looking at the glasses. Well, it's going to render the left and right frames. If anybody here is sensitive to flashing images, look away, because it's going to get a little scary in a moment. But if we turn this on, you'll see it gets very, very jittery. And what we're doing is that's the left and right frame being played simultaneously on the monitor. But if you look through the glasses, you would see them separately, and your brain would create that optical illusion. So that's the basic project idea. I'm going to walk you through some of the, turn off the balance board, walk you through some of the source code here and how it works. Hey, look, I got shorter. So Virtual Earth right now, you can actually create your own bindings and create your own control schemes using the keyboard or joysticks or whatever you have available. If you simply copy an XML file with the schema into your local profile Virtual Earth directory, you can set up whatever you would like. Now, I've created a couple of custom input types using the Wiimote and the VR 920. So you'll see there's a Wiimote.nunchuckX, which is mapped to the Virtual Earth built-in strafe function. So if we move the X on the joystick, you'll slide left and right. And on the nunchuck, Y is tap to move. So if you move up or down, it's going to move you through Virtual Earth 1 unit at a time. So this sets up all the buttons. And there's a couple of keyboard buttons, key.f1. These are actually the key event source is built into Virtual Earth. So these just toggle the balance board and whatnot on and off. So you can kind of run through the demo incrementally. So in our main form, what we want to do is create this globe control. And there's a handful of, after you install the Virtual Earth 3D control from maps.live.com, it puts it in the global assembly cache, and you'll be able to reference the Microsoft.mappoint DLLs. And then you can create a globe control. And while there's not like a UI designer for this, you can just manually instantiate the globe control, set a couple of properties, and add it to the controls collection of the form, and there you go. Now you have Virtual Earth hosted in your WinForms application. So when the application loads up, we're going to create our Wiimote event source and our VR920 event source, which I'm going to run through the code for, and those are the custom things that I wrote to take the data from the Wiimote and the glasses in order to display them on the screen. And we also need to set up any custom actions. So those keyboards, the keyboard shortcuts that you saw in the XML file that were toggling the glasses on and off and the balance board on and off, you have to provide a text name that matches what's in the XML file and a method that actually handles what that event does. And then the final thing we set up here is the VR920 stereo step, which is another piece of custom code that I wrote that gets added to the step manager. The step manager is basically a collection of objects called steps that will be guaranteed to run at the end of every frame that's drawn in Virtual Earth. So that's exactly what we need, because we need to render one frame to the left, one frame to the right, and put those in the glasses. So you can do that with a step. So let's look at the Wiimote event source. This is a pretty simple object that just inherits from the event source object, which is part of Virtual Earth. You provide an enumeration of any events that you want to be able to handle. And for us, it's every possible thing that the Wiimote can do, be it buttons, be it the motion sensors, be it the nunchuck. Everything is listed here. And in this, what we do is use my Wiimote library, find all Wiimotes that are kind of connected to the system, connect them, hook up the events so we can listen to the data coming in. And then when that data comes in, which is in the onWiimote changed event, read the balance board center of gravity, read the nunchucks, etc., and you call your local, which is part of the base class of event source, execute. And if you're doing something involving an axis with the camera, you are sending an axis event data, mapping the enumeration that's up on top, which would match what's in your XML file, and the actual value that should be passed to the Virtual Earth rendering engine. For buttons, I just have a little utility method here called handle button. This would send a button event data, and this is just something that would toggle on and off there. That's not an analog control to digital control. So it's the same idea, provide the enumeration, and you can specify whether it's activated or deactivated. That's if they're push the button or not. Now, the VR920 event source looks pretty much the same, except we're p-invoking to a couple of methods that are in the library and driver provided by the glasses. And these just allow you to open the tracker, set it to 0, so whenever your head is looking straight ahead, you can toggle it so that it'll be that's your home position. And git tracking, which provides you with a yaw, pitch, and roll. And those values are turned into degrees, which are then turned into radians, which are then passed to the Virtual Earth engine, and that's what renders the camera. And the final piece is that VR920 stereo step, which again, this is a second driver provided by the glasses, and a couple of p-invokes to open the glasses, to set the left or right eye. That tells the camera which eye to render the current frame to. And then wait for AC, which is which will sit there and wait until the eyepiece in the goggles has rendered that frame, so you don't wind up with tearing in the left and right side, even though you still kind of do. So VR920 stereo step inherits from the step object, which is part of Virtual Earth. And you have to override the onExecute method, and this is just what happens when that frame ends. And the only thing we're doing here is just we're grabbing the last reported position in Virtual Earth based on where you are in the world, and we move it minus eye distance and plus eye distance for the left and right eye. So we move it slightly to the left and slightly to the right, and passing that information back to Virtual Earth, setting the camera, and then we tell it which eye to render that into, and then to sit there and wait until the next frame is available for it to draw. So It's pretty simple code. It's not very complex. It's just the fact that it's not overly documented. I'm going to be writing a Coding4Fun article. It'll be up in the next couple of weeks after I get home and have the time to write it. Full source code, full article will be up, and that's We Earth VR.
Awesome. Very cool.
Thank you.
So next up is me, and I'm going to be showing an app I wanted to build for me personally whenever I travel. It's called InnerTube. So the goal is to have YouTube on your PC, meaning I want to be able to have my laptop. I'm going to be getting on a plane to fly out of PDC. I want to be able to watch YouTube videos, but I'm not going to have an internet connection. So plus, I also have different devices. I have a Zune and maybe an iPhone. No, we're not saying that. But I want to be able to sync to those devices. So how do I actually do that? And what I'm going to show you is InnerTube. It's a WPF application. It downloads videos from YouTube. It converts them into MP4, which you'll need for iTunes if you have it installed, or WMV if you have a Zune. And then it automatically syncs to them. And we'll show each of those different steps. So first thing I'm going to show you is YouTube, just a regular YouTube page. I'm just going to F5 refresh this. So nothing too spectacular here. What I want to show you is how to download a YouTube video with no code. And then we'll show you how to do it with code. So on a YouTube video page, I click View Source. And what I'm going to do is just search for something called Swift ARGs. So Swift is their actual Flash video player. And what I'm going to do is just zoom in here. And we see it passes a number of name-value pairs. The one we actually care about is this one. So we're going to need this to download the video, and I'll show you why. So first, I'm going to take you to the download URL, which is youtube.com getvideo ? and the video ID. If I just copy and paste this into a normal browser and click Enter, I'll get a 404 error. What's happening is YouTube is actually blocking you from downloading that video. What we need to do is pass in a session token, and that session token is built dynamically based on each video. So I'm literally just going to copy and paste this token. We'll go back to Notepad, add that token, add it as a parameter. Now it's the same exact page, but with the valid session token. Click Enter, and of course it decides to tell me that the token has expired. Ooh. So let's Control F5 and try this one more time. Or we'll jump on Italian babies in bikinis. That sounds like YouTube. OK, great. View source and get that picture out of there. Great. We'll do the same exact thing. Swift ARGs. So this is actually a good point because I had the video on. You will get a 410 error programmatically as well if you try and use a token that has expired. So we will just do a couple things here. Copy and paste this token. So now we have a valid token. And we will also just make sure we have the right video ID. And we will try this one more time. Copy and paste. And with any luck, ooh.
How long is the session token for? Seconds? What? I update the token.
Oh, did I not update the token? Oh, yeah, user error. Thank you all. I love this live debugging feature. We should ship this with Visual Studio. OK. This time, as you can see, it's kind of a pain to do. Now, we can actually download this video. So this is an FLV file. So let me show you how to do this programmatically so we don't have this pain of copy and pasting valid session tokens. So I'll quickly show you InnerTube. We see a bunch of videos. These are all local files. So if I go to this videos page, I see I had the MP4 and the WMV file format. And if I go into iTunes, these has synced those same videos, and you can now take those offline. So if we jump into code to download a video, and I'm just going to full screen this, we take a video, and what we do is we make a request with the video ID and that create token request, which I'll show you in just a second. And one thing to note is because we're downloading potentially 25 or 50 YouTube videos, make sure to use the web request because it allows you to set a session timeout. If you try and use a web client, you'll actually have timeouts as you download these videos. So we download 65K of this file stream at a time and then just save it to the disk. Now let's jump into create token request. And what this is going to do is request that HTML page. And in this case, it's going to download it as a string. So I have this raw HTML. And then what I'm going to do is parse out. We're looking for that SWF args JavaScript variable. So we're looking for this. Once we find that SWF args, we need to read the name : value pairs. So the one we need to do is find that session token. And we literally just loop through, find the index, and do a little bit of screen scraping, get the values, and return t equals the session token, which should be exactly what we had done before. So t equals. So at that point, we've downloaded a video, and we've shown how to do that programmatically. The next thing we need to do is convert it into a format we can use, because if you have Flash video, unless you actually build your own HTML page, you can't see it. So to convert a video, we're using a tool called FFmpeg. So this is an open source application, and it's literally running at the console. It's ffmpeg.exe. You pass in a certain number of parameters, it'll convert a Flash video file into MP4 or a Flash video file into WMV. Now, the nice thing about it is we can actually add the YouTube video metadata. So this is what we would pass if we were, say, downloading Chocolate Rain, these hyphen title and then the name of the parameters. Here, we can actually pass in YouTube videos. So what that means is the video is actually encoded with those settings when you go to details. We can actually see the title, the comments, and other metadata about the videos burned into the file directly from the YouTube object. Now, the one thing I'd call out is because this is a console, we're making sure to hide this. So it does the conversion, we hide it, we redirect output, and make sure to turn the shell execute. So it's running in the background, it's actually building its own process, doing the conversion, and once it's done, the last thing we need to do is to do a sync to iTunes. So iTunes has a library, and I'll just show this real quick. Oh, it's actually in this library. So buried in here is this iTunes lib. Anytime you install iTunes, it automatically adds this COM library. iTunes actually has an SDK that shows you how to do some stuff. So I'm actually running here. But we have a library playlist, and all we need to do is say add file. That file just needs to be the location of our file. So we will loop through the directory we showed before, except we're going to filter and only add MP4 files. And the reason we do that is because iTunes doesn't support playing WMV files. But that's all we need to do. And this library is pretty easy. If I want to say itunes.libraryplaylist.play, I can easily automate iTunes with this. And the Apple iTunes SDK actually includes VB and C# code, which is kind of cool. Now, the last thing is to show Zune. So let me full screen this. So the way Zune works is Zune doesn't have a COM SDK that we can plug into. But what it does is actually have a set of folders that it monitors. So what we can do is sort of reverse engineer how Zune works. And what it does is when I say add a library to actually track, it goes to Software Microsoft Zune Groveler and adds that directory. So if we want to add files, all we need to make sure is that directory we showed earlier, this specific path, is copied into that registry key. So, and the nice thing about Zune is that if we actually delete the file, it keeps it in sync. So it's like a real-time monitor, and the Groveler is basically keeping real-time. So as I delete something in my file folder, it's also deleted in my Zune. So if I need to add 100 video files, I literally copy-paste, make sure that directory is in there, and that's all we do. So that is InnerTube. So Scott, you are up. Thank you. Let me jump to slides.
Cool. This is my son, and this is the face of pure evil, as I said in my talk earlier. He destroys things, so I figured why not point him at my computer and let him destroy something while possibly being productive. Go ahead and switch to the next one. So I had a talk earlier called TL49. Did anyone go to that talk? Okay, cool. In that talk, we built this application. We took an application called Baby Smash that lets kids smash on the keyboard. It does colors and lights and sings and stuff like that. And we put it on the web, we put it on mobile, we put it on the Surface. And what I'm going to talk about in this talk is some of the more detail on what it was like to port a WPF app over to Surface. Let's go ahead and switch me over to here, and let's get into some more detail than I was able to do yesterday. You can go and get this game if you have a baby or if you just like to smash things at babysmash.com. If we go over to babysmash.com and click on videos, you can see what it looks like when a baby's playing this game, just to make sure it's clear. Usually involves a lot of laughter. There's lots of pictures of babies playing the game. And you can go and go up to windowsclient.net, and under the Learn section, you can get the code, you can see articles, because we're basically trying to learn WPF. It wasn't just for my son, it was also for me to learn WPF, because I found WPF to be a little daunting. So I decided to write it, and then I'm getting the community to contribute. So there's lots of people who are contributing to Baby Smash and improving it. It's open source. You can get it at Codeplex. I'm going to ultimately turn it into like a speak and spell educational game. So if you're interested, please get involved and check that out on Codeplex. The game looks like this. It's a click once application, so it's going off to update. And the kids can do stuff like this, and they can... And there's an options dialog that pops up, and the kids can decide whether they want laughter or they would want speech. So it'll say, you know, A or red square or whatever. There's all sorts of options. I had this dialogue actually designed for me by a designer, so I got to just see how I could create some XAML and have it be ugly, and then I could hand it to a designer and have it be pretty. Now, this is all a WPF application. Because it used XAML and because I used the language that I knew, which was C#, it was really easy to port this over to a Surface. I've got the Surface simulator here. Just run the Surface simulator. It's going to pop up like this. And this really acts exactly like a Surface would. We'll get the initial startup screen here. And this is called Attract mode. So this is there are regular applications and there are Attract applications. Just like a video game, it's meant to have you see it and go, ooh, I want to see that. So we've got some kind of water here, and I can use my mouse to move the finger around. And that is trying to represent the finger that I would be touching with. There's no mice and there's no keyboard on a Surface. I can use the mouse wheel and I can rotate the orientation of the finger, because the Surface will actually tell you not just that you touched somewhere, but what direction they think your finger was at the time, so people can be working from different sides of the table. But I can also hook up multiple mice. I've got two mouses, and the trackboard. So I can move both mice like this, and then I can move the third one with my tongue.
Very nice.
So you really get the true Surface experience. If I click on the launcher, I can see all the different Surface applications that are available, and there's Baby Smash. And this is just a WPF application that has the Surface libraries and some of the Surface extensions to WPF. You have a timer going so I know when to shut up?
What did you say?
Cool. So if I click around, these things pop up. And I can resize them. Now you notice that I've got those little Polaroid things around it. That's because I'm using a thing called the scatter view. Now originally when I was doing this with WPF, I had a canvas. I would make a user control. Each of these shapes is a user control. And I would say canvas.children.add, and I'd put the shapes in there. In the original game, it's keyboard-based, so the shapes are random. In the Surface game, I want to know the location, so I have to take the X and Y where they touched, and I add it. I didn't want to add it to a canvas because once it's there, it's just sitting there. I can't move it or resize it or scale it or do anything because none of that's built into a canvas. A canvas is a WPF thing. Surface has a thing called a scatter view, and it literally just means give me a bunch of stuff and I'll scatter it around. A lot of you guys have probably been doing the scavenger hunt. You've seen photo applications. A lot of that is built in by the scatter view. That outside bit is what scatter view will give you. If I go back over to my code, and I'm using Visual Studio Express, This was the original canvas that I was using to put my shapes in the WPF version. And then in my code, I was just saying canvas.add. In the Surface version, I derive rather than window, I derive from surface window. I just had to change the hierarchy there. I put in a scatter view. Now here in the XAML, I could go and say width equals 400 and height equals 400, and then remove this style. And then suddenly this appears in my design view. That's what you would expect to see when you draw a scatter view and you drop it on your system there. But I want to remove that back area. I need to get rid of that. So what I do is I go into Blend and I take that control and I say make a copy of the template. The template is like CSS, but it's for WPF, and it's the default look that a scatter view has. So then I named that new style the scatter view baby smash style. I said, I don't want you to look like you usually look. I want you to look like something else. Blend will make a copy, so it still looks the same. It's basically extracting the style and then expanding it for me and inserting it as a resource. It would be like right-clicking on a text box in HTML and then saying, I want to override all of this, but it's generated all that CSS for you. The smash style is up here, so then I just went in and took that generated style and I said x:null. That's the WPF way of saying nothing. So I made the background nothing, the brush nothing, the foreground nothing. I effectively made that scatter view chrome invisible. It's still there, it's just invisible. Now in the code, during the porting process, rather than adding it to the canvas, I make a new scatter view item, set the point in the center. I put my user control C as content. So we're building a hierarchy. I've got the scatter view, I make an item, and I put the control in it. And that's what we just saw. If I want to make that disappear, I have to set the style, because I'm making these programmatically. So I would take style, and I would bring it up here. So now I pull that style out of the resources, and I add it to my new programmatically created view item. But that doesn't get me resizing. That would just get me the ability to resize the Polaroid looking deal. But the thing inside would actually not resize. That I need to use a WPF thing called a view box. And a view box will take whatever's inside it and make it bigger automatically. So I'm going to make a view box, make its child the control. Then I put not the control in the scatter box, but I put the view box in it. Okay? So we've got a scatter view item, view box, and then my control. Then I also have a couple of events that you don't get on WPF because you don't have a mouse, you don't have a keyboard, you have contacts. So these are attached events that the Surface SDK gives you, like contact down and contact leave. So I put in contact down, that's where you add the figure, and you get the position of your finger. And then on contact leave, when they touch their finger and they remove it, I'm going to have it play a sound. This was all that I had to do to make this happen. Then I just run it. So now I can take my two mice. I can pick one of these up and throw it around. I get all of that for free and make a really creepy one that stares at you. This is running on the surfaces in the Expo Center. So if you want to play with this yourself, take a look at it. It's in the Expo Center. You just walk in to the right. There's two sets of 4 surfaces. There's the hands-on labs, and then there's the other ones over by the open space. The open space ones have Baby Smash on all of them. I'm going to put the code up, and I'm going to do a series of articles. If you want to see your articles, your blog posts up on windowsclient.net, get involved. Let me know. Just email me at scottha@microsoft.com. If you've done something to make this better, then let me know. We'll do a series of articles, and we'll promote you on the windowsclient.net website. That's what I got. Thank you very much.
Awesome. Thank you. Okay, so how many people in the room use Twitter? Oddly enough, it's I'd say about half the people in the room use Twitter. So for the other half that don't use Twitter, Twitter is a micro blogging community. You get 140 characters to tell people what you're doing right now. And the nice thing is then all your friends can say, hey, you know, I'm over here. So last night, we found out where the parties were at through Twitter. So you should pop on Twitter. We created, go back one. So what we did was we created a polling application. So the cool thing is well, let's say where do you want to eat tonight? Do you want Chinese or Thai food? So what you can do is you can create a comma delimited list, or you can create a number range list right now, or a number range poll. So how we set up the application is a very simple ASP.NET application. You have your default to ASPX, which calls your polling class, which then calls the Twitter service class. The Twitter service class then calls a REST API from Twitter, which there's an example of it. I'll show you the XML that you'll get back later. We parse it through some magic link, and then we send back up the results to the default ASPX, and then we send it to Popfly to create a rich polling chart. And the list that we send to Popfly is a pipe delimited list. Go to the next. I think now it's demo. OK. So for those who haven't used Twitter before, this is what the new user interface looks like. This is my Twitter account. So I'll just say hi from PDC. And post. And now all my friends will see, you know, hi, I'm posting from PDC right now. Now what we do is we have our master account. This is my personal account. Pardon for using Firefox here. So now this is the Coding4Fun account, and I'm going to prep people and say, hey, I'm going to create a poll. I'm going to click post, and then now I'm going to say poll, Twitter, Wiimote, YouTube, or Baby Smash. Now,
you forgot a project.
That's 4. There's 4 of us.
Okay, you got him.
So, anyone in here who wants to vote, all you have to do is reply to Coding4Fun. You don't even have to follow us, and type in Twitter, YouTube, or Baby Smash. And the really cool thing about Twitter is it works on your cell phone. You can text in to Twitter. You can use m.twitter.com. You have a ton of applications also, and you can just go to twitter.com to actually go there. So if you want to post, go ahead. So just as a quick demo here, I'm going to actually respond to Coding4Fun. So it actually has data. And because I'm egotistical, I'm going to vote for myself. So while that's actually getting results, actually really quick, I'm going to show you what a end result will look like.
Can they start voting?
Yes, you can. The poll is live right now. This is a poll that I set up earlier today just to test it out. So you see some real-life data. It was just all 3 of us voting for ourselves, so it's not really a true poll.
So Scott, who are you voting for?
Not sure anymore.
So really quick, so here's the simple page. So we have a get poll class, and that poll will grab it from the cache. So we don't want to constantly recreate the poll if we don't have to, because Twitter has a limited amount of API calls you can do. So in our poll class, once we get data back from the Twitter service, we have to poll it. So we just really quick say, is it a number or is it a comma delimited list? And then we just simply parse it through it. And then through the, where is that? Sorry. And then Twitter service, we call the REST-based APIs. And here you can see a simple URL, such as getting the user timeline. So let's actually see what that XML looks like. So as you can see, this is the Coding4Fun user line. And earlier today, I decided to poll who likes turkey bacon or normal bacon better. Personally, I prefer normal bacon. This is an ongoing argument. So after we get back the timeline, we call convert Twitter XML to a list. And through the magic of LINQ, it magically converts it into a list and return it back to us. And then we send that data
to the draw popfly results and create a pipe delimited list just through a simple for loop, and then we send it to popfly. So then if we test out this application, hit F5, this should show us the current results right now of who voted for what. And Baby Smash is winning.
Ouch.
I know.
Hey. Was that like, how many votes is that?
I
voted 6 times. Does that matter?
Yes. And if you guys have any questions about the code, we talked really fast about this. We will be outside because we have a very, very limited amount of time. So we'll answer any questions you have.
Okay, we actually have 9 minutes, so we can probably take some questions. I'm just going to go through some resources, but thank you, Clint.
Thank you.
So yeah, head on over to @Code4Fun, is it?
Yeah, coding for
Coding
fun.
and the letter 4, fun.
Coding, the number 4, fun.
So real quick, we do have a Coding for Fun book, so if you want to learn how to program X and A, do some cool stuff with popfly, learn how to do some VB and C# with World of Warcraft, build peer-to-peer video, InterTube, Twitter vote, hacking remote control cars that you can actually see in the Channel 9 Coding for Fun lounge, and a bunch of other cool projects. Order now. So other thing is popfly. They wanted us to give a shout out to DevLabs, which is a new resource. You can actually go to msdn.microsoft.com/devlabs and see projects like Small Basic. And then finally, this is really the resources. So we can probably take a couple of questions, but then we need to run out. So if you all have questions. But thank you all for coming. Thanks. Is there questions?
Cool. If anybody wants to play Rock Band, I'm going to go over to the Don't Fear the Reaper simulator, and we'll be doing that soon. Do you have a question, or are you just hanging out? No? All right, let's go over and play Rock Band. Okay?
Question over there.
There are, as I understand it, 18 surfaces. There are 4 diamond-shaped in a set of a diamond. So you walk in. On the left, there's the... Oh, build? Oh, I have no idea. I didn't count them all.
Can you pull up the poll?
Can you order one? So the guy to talk to, his name is Brian Sanderson, and he's sitting in the Surface booth, and he's the marketing manager. So if you have a thing that you want to use it for, if you want to use it for hotels or for medical imaging or whatever, he'd be able to tell you how to get a Surface, how to get a dev version, how to get a production version, how many there are, and what your space is. Because it's not just the devices, it's also a complete platform. So yes, Brian Sanderson. And if you want to email me, I'll get you his details. He's the partner manager. Good question. There's a 10% discount of what? Oh, if you're at PDC, there's a 10% discount on a Surface, too. So it's only $1 million.
Awesome. So we'll be outside if you all have any more questions, but thanks all for coming.